Hello class, happy week 8. I am still on my travels. I was in Seattle for 2 days and now I'm in upstate New York at my in-laws. I guess you could call it kind of a horse farm if you can see some animals in the background there. So, hey, we just finished our second quiz and awesome. You guys did, like, again, the best ever. Normally I see the scores start to tank from quiz 1 to quiz 2 to quiz 3 and then the final exam. However, your scores, your averages went up. So what you'll see is, again, what I did is, I don't curve. I look for the one item on the test that you guys did the worst on, which happened to be the last one about the central limit theorem and sampling distributions. For some reason, a majority of you didn't do too well on that, so I marked that as correct. So subsequently, pretty much everyone's scores went up quite a bit, so hence the overall average. So awesome. This week, I was thinking about not doing a discussion activity. However, this week's discussion activity, because our topic is we're getting into testing the difference between two means and hypothesis testing and confidence intervals for the mean. And the activity actually has a couple videos which show you how to do this, particularly in Excel and or my stat lab, because the t-test, the one sample t-test, there's no easy way to do it otherwise than doing it manually in Excel. So the video shows you how to do that. So there is no nothing in the data analysis tool pack. So I was like, well, at a minimum, they at least should try this out. So you need to know it. So there it is. Now, one thing I wanted to tell you about with hypothesis testing, this thing called the null hypothesis and the alternative hypothesis. These are just methods. They're, I guess, the conceptual framework when testing the differences between, let's say, the scores of two groups of people, or a pre-test and a post-test. This concept of null hypothesis is a given. It's always going to be there. Basically, the null hypothesis means there's no difference. It's a I guess philosophical fact, if you will, that is always going to be there when you're doing any sort of statistical test between two numbers. So just something you should know. Null hypothesis means no difference. Your alternative hypothesis, however, is basically, it's up to you. It's the question you're trying to answer. So did this group score better than this group? Is this score bigger than the population average? Or is it lower? And then we get to these things called tails, one tail and two tail tests. Okay, and so you don't get confused on that. What that really means is the tail is the direction of the hypothesis. If you're basically saying you're looking at if scores, performance, or whatever it is higher than whatever you're interested in, that's usually going to be a right tail test. Okay, sorry, there's horses here and there's like flies and bees and stuff like that, so it's kind of nasty. But then a left tail test is an alternative hypothesis where your research question really is performance lower than whatever the average or expected baseline that you're interested in. Now, a two-tail test is kind of an open-ended alternative hypothesis. That's basically you're saying, well, we expect scores or performance or whatever it is to go in either direction. No matter what the direction is, we're going to test both sides. Okay, so left tail, right tail. So that would be two-tail test. So just to clarify, one tail would be left or right, depending on your question. Two-tail is both left and right side of the distribution. So as you start to read and play around with the statistics, you'll get to see that. But it's just something you need to be aware of with hypothesis testing. So if you have any questions, obviously just ask. So again, I'm here in New York till the 14th. And then on the 15th, I hop over to Hawaii for a couple weeks. So, all right, I hope all is well with you guys. And you have a happy 4th of July. Let's have a great week. Ciao.